Hello class. Today we are going to learn about Newton's laws of motion. As you know that we have three types of Newton's laws of motion. We have the first law, the second law, and third law. So today we are going to discuss about the first law of motion. So Newton's laws of motion describes to a high degree of accuracy how the motion of a body depends on the resultant force acting on the body. They define what is known as classical mechanics. They cannot be used when dealing with, number one, speed close to speed of light, that is 3.0 times 10 power 8 meters per second. Number two, very small bodies, that is atoms and smaller materials requires quantum mechanics. Newton's first laws of motion: a body will remain at rest or move with a constant velocity unless it is acted upon by an external force. Note that the instant velocity means constant speed along a straight line. But two, the reluctance of a body to having its velocity change is known as inertia. Examples of Newton's first law of motion: number one, we have somebody pushing a load. Remember, we have the force of friction which opposes the relative motion. Number two, second figure there, we have a coin on top of a cardboard, and then we have an empty tumbler. So when you flick that cardboard, the coin will just remain and fall into the tumbler. So the box will only move if the push force is greater than frictional force. So you have to overcome the frictional force for the object to move. Second diagram there, when the cardboard is flicked, the coin drops into the glass because the force of friction on it is due to moving card is too small to shift it sideways. If the push force equals to frictional force, there will be no net force on the box and it will move with a constant velocity. Newton's second law of motion, which states that acceleration of the body of a constant mass is related to the net external resultant force acting on the body by the equation. Resultant force is equals to mass times acceleration, which is equals to F equals to ma. Therefore, F is equals to the force, m is the mass of the object, and a it is the acceleration. Question 1. Calculate the force required to cause a car of mass 1200 kg to accelerate at 6 meters per second. So F is equals to ma. From the previous discussion, we have force, which is equals to mass times acceleration. So now that we have the force, that is the mass of the object, which is 1200 kilogram, and then we have its acceleration as 6 meters per second squared. F is equals to 12,000 kilogram multiplied by its acceleration, which is 6 meters per second squared. So force will be 7,200 newtons. Question 2. Calculate the acceleration produced by a force of 20 kilonewtons on a mass of 4 kilogram. So this gives us that 20,000 newtons is equals to 0.40 kilogram times acceleration. So for us to calculate the acceleration, we make A to be the subject. So acceleration is equals to 20,000 divided by 0.04, which will give us acceleration as 5.0 times 10 power 5 meters per second squared. Question 3. Calculate the mass of a body that accelerates from 2 meters per second to 8 meters per second when acted on by a force of 400 newtons for 3 seconds. So our acceleration is equals to change in velocity per unit time, or acceleration is equals to the rate of change of velocity, which gives us that 8 meters per second squared minus 2 meters per second squared gives us 6 meters per second. You divide it by time, that is 3 seconds, gives us 2 meters per second. So force is equals to ma, which is mass times acceleration, gives us 400 newtons, which equals to mass